Sidhu,
Okay.
I just wanted to update everyone that everyone should keep their real name on Zoom as well, because we'll be marking all of yours attendance after this call. So it would be very difficult for all of us if like you guys have registered with some other name and joining from some random name. So if we can do that, that is going to help you as well in getting all the NFTs after the course completion.
And now I'm curious. I saw a name called It's Curious. So what is? I'm curious about the name. What's up? What's up? Yeah, now keep the chat going. Like any new learnings? I don't see much chat happening in Discord. Guys, you can post all the questions, doubts, anything that you have in Discord too. Like I have both the screens open, so don't worry. We are not missing any chats here. So what's up? What's up? Yeah, let's see a couple of guys joining in. Yes, guys. Yamin, Devashish. I don't know if I'm butchering a lot of pronunciations, but I'm trying my best, guys. So today is your first code camp, right? So I see a lot of you guys already completed it, but for people who are starting out or people who are new to Web3, we'll be writing your first smart contract. We'll be playing around with the whole concept of smart contracts. So the idea is like that by the end of the road to Web3, you have to build something, right? Like you have to build an application, that will just or with your friends or or solo. Yeah. Everything goes into place, like internships, all that comes right after your kick-ass application. Like once you have your application, you have a portfolio, right? So these code camps are generally there for helping you get that knowledge or knowledge base. Like we have code camps that help you understand smart contracts, NFTs, how to build an end-to-end apps and stuff. So all these, think of it like you're building a puzzle, right? You need the pieces. So just like that, at the end of the cohort, you have to build something. So these code camps are basically puzzles that helps you fill in all those areas. Like if you're a beginner, this is where we start. Like the code camps will give you that knowledge to work with smart contracts, to work with NFTs, ERC20s, end-to-end dApps, all those kind of things. So these code camps will be all about coding and building or showing you how to do stuff, right? So yeah, that's the general overview, but you'll know more about this as we go through the code camp. How many of you actually have written a smart contract? Let's start there. At least one smart contract. Me, okay, nice. Oh wow, Shantanu, almost 20, dude. I have in the game, nice. Right. Today that's great. Mahanshu says today it was yes, that's awesome. So that's the thing. See, yeah, somebody wrote half a smart contract. I'm curious. Like I know what half of a contract or what kind of a contract was that? See, that's the thing. Like for people who have already written a smart contract, this is going to be a sort of a recap kind of a thing, right? Before you start building your application, you can just brush up your knowledge about smart contracts and everything. And for those who are writing it for the first time or preparing to write your first smart contract, this is the code camp that you need. Like we'll take you through all the steps, and by the end, you'll have a firm understanding of what smart contract is and how to write it and how to deploy it and everything, right? So this is like we will do this via a course, a MetaMask course, like sorry, MetaMask. What am I doing? MetaSchool course, where we will take you through the course, and that course basically explains how to do all that. So I'll give you a very thorough walkthrough of it, so that you can code along if you want. Like if your internet is fine, if you're using your system, you feel free to code along, right? And share doubts or questions or help each other out. Or if not, like try to complete it maybe by tomorrow or something. Like I see a lot of people have deployed their smart contracts and stuff. Yeah, I mean, congrats. Is that your first smart contract? Yamin says like, oh, nice. Cool. Oh wow, we have a lot of people who are like writing their first smart contracts. This is really nice. So by the end of Road to Web3, you guys will have your own, like from writing your first smart contract to building your first dApp. That's the journey. That's Road to Web3, right? So this is really, really cool. So yeah, any, we'll just wait for 2 more minutes and then we'll start, right? So yeah, anything else other than Web3? Any other technologies that you're looking into? I see that AI is huge. So any AI ML developers, data analysts here for checking out Web3 too? Oh, nice, nice. Anybody else who's AI is Getson? You're AI. You are in the AI camp. I thought given the things that you're building, you are in the Web3 camp. Oh, wow. This is news. This is news. Yeah, the question was like, is there anybody who's exploring other techs like AI and stuff, AI, IoT, or anything, or data engineering? That's good. That's good. AI being present, always an enthusiast. That's nice. That's nice. You can also like do put. I see that the Discord channel is a bit quiet now. You guys can also chat in the Discord channel. Like I have that open. So even if you put your messages there, put some GMs and stuff. Know that we have started the session so that others will also join in. Want to learn with deep learning? Yes. Any fans of generative AI? Like, have you guys tried something building some GPTs or something like that? That is probably problem looking to if put it in that, then we can get started, right? So yeah, so all of you, welcome to the first LangChain doc. Yeah, okay, Andrew. Okay, okay, I'll definitely check that out. Thanks, guys. That's cool. So I guess we can move from the AI camp to the Web3 camp now. So welcome everybody to the first code camp. So in this code camp, like the whole idea is to help or help you guys understand what smart contract review is, right? I'm sure like a lot of you have already created and deployed the smart contracts. There are a lot of people who created their first smart contract today. So no matter where you are, consider this as a recap or your go-to online session to understand or have a better understanding of smart contracts, right? So let me just what you have to do is, I think it was specified in the mail, but before you start the code camp, make sure that you have enrolled for our course. I'll just give you the link of the course right now. So those who haven't, please enroll for this course. Just give me a second. HTTP playlist on prompt engineering. Okay, I'm saving all this. So I'll just
I can share it if you want.
Yeah, sure. If you have the link, do share it.
Sure.
Yeah, I mean, so in order to avoid spams, that's why we do that. But if it was by accident, do let us know. Do ping us on LinkedIn or Twitter, and we'll just unblock everybody. So awesome. So let me just share my screen. Yeah, I'll show you. I'll show you where you can see your NFTs. Like at the end of the course. So yeah, so you have the course. Write your first Solidity smart contract on Ethereum, right? I think a lot of you have completed it. A lot of you have tried it out today. Yeah, thank you, Nitin. Thank you for that. So let's talk smart contracts. So let's just break it down. What the contract? You can post it in Discord or anywhere is fine. What's the whole idea behind a contract? You're writing smart contracts. So a self-executing code, agreement between parties. Okay. Anything else? Agreement with a set of rules to be followed. Okay. Okay. So I see a written agreement. Okay. So to interact with I'm not talking about Web3. I'm just talking about contracts in general. Okay. I'm just talking about contracts in general. So what's the whole idea there? A contract, an agreement. Okay. An agreement, yeah, smart contracts, like we'll get to smart contracts, but right now we're just sticking to contracts. So everybody agrees that it is an agreement, right? And what does that agreement contain? What does that agreement contain? Like everybody agrees that a smart contract is an agreement, right? Guys, the Discord channel is essentially quiet, so do put a lot of chat there. I see Nitin has posted a screenshot. Good job. Terms and conditions. Okay, a set of rules, right? So you have an agreement that is essentially a set of rules that everybody agrees to, right? You can I define a contract as can I describe a contract as a set of rules that everybody agrees to? Is that a fair definition? Yes or no? Yep. Thumbs up, thumbs down. Right. So it has a set of rules that is agreed upon by everybody. Now somebody mentioned that it is always written, like it's a written agreement. Right. If there is any issue with my voice, just let me know. Like I think if you guys are facing an issue, okay, cool. So yeah. So the question is, it's a set of rules that everybody agrees to, and oh wow, is it okay now?
Yeah, Sethu, I think now it's fine. Previously, it was breaking for all of us.
I think I'll just okay. So yeah. So my question is, somebody mentioned that it is a written agreement. Should the contract be always written? Should the contract be always written? Yes or no? It can be typed also. Okay, that's a. I mean, typed, written, whatever. Yes, yes. Okay, here's a situation for you guys. I verbal. Okay, let's see. See, here's the situation. I go to my local supermarket and I buy myself a packet of chips. Do you think there is a contract there? No, no. A legal contract, it can be, yeah, it can be anything. Like the situation is pretty clear, right? I go to my local supermarket, I buy a packet of chips. Do you think there is a contract there? Your money as a contract, yes. So if bill, yes. So is it written? I mean, are we signing anything, or are we just do we take our legal team to the supermarket to buy a packet of biscuits? How does that work? Or where is that contract there? Where is the contract there? Price, bill, okay. Trust, price is mentioned on the pack. Yes, you are given a receipt. Okay, the receipt comes, or the bill comes after the transaction, right? It's mutual understanding. Okay, see, again, let's money as okay. We are going to territories of fiat contract system. Nice. See, what you have to understand is you guys, yes, there is consensus of rules to follow. That's exactly what I'm getting at. See, we all agree that a contract is essentially a set of rules. right? It's a set of rules that everybody agrees to, or both parties agrees to. So when we go to a supermarket to buy something, what are the rules that we are following there? From both sides, what are the rules? Give me some examples of the rules that we are following there. You go to a supermarket, buy a packet of chips. What are the rules that you are following there? Give money, you pay the asking price, okay. Give money, take product, yes. The product shouldn't be expired, right? It should be of good quality. There shouldn't be any health hazard. You should not just pick up the money and product and run, right? These are all the rules. And sorry, when you're buying that packet of chips, both of you guys, like there is some rules that you as a customer has to follow, and there is a set of rules that the other guy, like the shopkeeper, has to follow, right? And you mutually agree to follow that rule, right? Now let me ask this question again. Do you think there is a contract when you're buying a packet of biscuit or chips or anything, right? See, yes, it may be non-verbal, informal, whatever, but the general rule is, if the action that you're conducting, right, if the action that you're conducting is of a transactional nature, okay, if the action that you're conducting is that of a transactional nature, there is always a contract. Do you guys understand? Any questions or any counter arguments to that? If you are conducting an action that is of a transactional nature, then there is a contract. It can be verbal, it can be non-verbal, it can be written, it might be typed, but there is always a contract, because a transaction should always be guided by a set of rules, right? And when you are conducting these transactions, you need to follow, or you need to agree to these rules, so that transaction could move forward. Yeah, so it's yes, it's not actually, like, if it is a transactional action, meaning you are exchanging something, then there should be, it's not a give and take situation. There is a set of contracts, there is a set of rules that you have to follow, right? So what exactly is a smart contract? We talked about contracts being like rules and everybody is following those rules, right? So what exactly is a smart contract? How does a contract become smart? We have smartphones, smart TVs, right? So what exactly is a smart self-executing? Yes, can you elaborate on that? Automatic, yes. Yeah, so the thing is, Jimmy, so the thing is, anything that deals with, yeah, so any kind of such action that involves a transfer, right? So the idea is that any kind of action that involves a transfer will have a contract that guides it. Okay, that's the thing. Like if you're transferring something, like in the case of me going to the supermarket, I'm transferring money for a packet of chips. And like if I'm going to a car dealer, I'm transferring money to get a car. If I'm going to buy a house, I'm transferring money to get or buy a house, right? So in all these scenarios, the action is of a transactional nature, and there is a contract that will guide that transaction. Do you understand? There is always a set of always a set of rules that will guide that transaction, right? And it is not a mandate that rules will be written or non-verbal or verbal. It can be anything, but there is always a set of rules when it comes to an action that is of a transactional nature, meaning if there is some kind of an exchange happening. So my next question is, what is smart contracts? A piece of rule written with solidity code. Okay, is that the final definition? What makes it smart? That's the question. Self-executing, yes. See, let's go back to the supermarket scenario, right? Imagine, so you have a shopkeeper there giving you all the products and stuff, right? Imagine if what will happen if we replace the shopkeeper with a vending machine. You guys know vending machines, right? Right? You guys know vending machines. Yes. Right? You just press a few buttons. You press a few code. You just pass it the coins or money or whatever, and it gives you the product. Right? So is the vending machine also following a contract? Oh, you have never seen a real vending machine. It's always there, like malls or somewhere. You'll find it. It's pretty simple. It's a mechanical device where you just put some code, put some money, and it will give you the product. So the question is the vending machine also following a set of rules? Or is the vending machine also following the contract? Yes, obviously, right? But here the difference is you don't need a middleman. Like in the case of a shop, the supermarket, there is a shopkeeper who acts as this kind of a middleman who helps you with the transaction, right? There is this middleman who helps you. Like if you are going to buy a house, there is this real estate agent who acts as this middleman or this intermediary who helps you with the transaction. But when you look at a vending machine, you are directly interacting with the machine. No human intervention is, yeah, just like ATMs. Yes, sort of like ATMs, right? There is no human interaction there, right? It is self-executing. You don't need anybody's help to conduct that transaction with a vending machine or an ATM. Am I right? So with these machines, what we are essentially doing is we are removing the third party and we are directly conducting the transaction without the help of a third party, right? With the banking people, we have ATMs. With the shopkeepers and everything, we have the vending machine, right? So like if there is any I can be wrong. Like we have developers and people here, so I can be wrong. You can object, you can raise your opinions if I'm wrong. No issues there, right? But you understood the concept, right? Instead of a shopkeeper, we can take a few mechanical parts, write some code and create a vending machine that can actually replace the shopkeeper, but that vending machine will take care of the transaction without the help of a third party. That scenario is very much possible, right? Yes. Do you guys understand the whole situation? We replace with a vending machine, we can essentially replace a shopkeeper, right? So a smart contract does the exact same thing. Okay, we can take the rules of any given transaction that is happening. It can be buying a house, it can be voting, it can be selling a digital token, it can be anything. You can take all these rules of all these kind of transactions, you can create a file out of it, a programming file out of it, and run it on top of blockchain. So just like a vending machine, you have this code that takes care of the transaction without the need for a human intervention or without the need of a middleman. Do you guys understand? It is just like a vending machine, or the principle is just like a vending machine. In a vending machine, you put the coin, you press a few buttons. In a smart contract, you give the data that is required for that transaction. Okay. And just like the vending machine, it will validate the data and conduct the transaction. So you guys have heard like the property of a blockchain. Like we always say this, like blockchain can actually remove intermediaries and stuff, right? The smart contract is the component that helps you with it. Yes, I am using Linux. I'm a huge Linux fan. This is Windows system. Yes. So anyway, coming back to the topic, do you guys understand the fundamental principle there of what a smart contract is? Any questions or doubts? For those who are starting out, is there any questions or doubts there? Yes. So yes, exactly. The smartness comes because it is able to conduct a transaction without the need for a human intervention, right? It can figure out, like when you write the code in such a manner that you codify the rules and you give it enough, or you program it in such a way that that program can itself take care of the rules. right? That piece of code can actually verify the rules on its own. That's why it is called a smart contract, because it doesn't need anybody to verify the rules in its rules for it. You have the code written and it is deployed in the blockchain, and it can take care of itself, both the rules and the verification of the rules. That's why it is called a smart contract. It is a contract by default. It is a contract, meaning it is also a file that contains a set of rules. It is a smart contract because it is able to verify the rules and also conduct the transaction without the help of another intermediary. Do you guys understand? Any questions or doubts? Like those who are starting out, is there any questions or doubts there? Just think of it as a vending machine that you're creating using code. But this vending machine, it not just gives you products, you can use it for selling houses, cars, digital NFTs, or whatever, without the help of middlemen. Is the concept clear? So next time when somebody asks what is smart contract, don't say that it is a vending machine. Say that it's a self-executing code that has a set of rules and that is deployed over a blockchain. But the principle is that of a vending machine. Right? Any questions or doubts? I'm not seeing much. Is that a yes or a no? Yes. No doubts, no doubts. Okay, cool. All right. So that's what we are going to build today. Here. Okay, cool. So none. All right. Awesome. So we are going to build a smart contract, right? We are going to write a smart contract and deploy it. Okay. So this is yeah. And before we do that, we need a set of things, like we need some prerequisites in our system, right? We need Node. What is Node? Node.js. Anybody familiar with Node.js? What is Node.js runtime? Yes. So yeah, we are going to be, yes, exactly. I mean, that was a silly question from my end. I mean, everybody knows Node.js, right? So, so before we start, make sure that you have installed Node.js in your system. Okay, the latest LTS version, right? You can get the link from here. Download the latest LTS version, right? And you need a IDE, right? You need an IDE or a code editor. Like this VS Code is basically a code editor, but you can use your own IDEs if you want. We prefer VS Code because it has a lot of cool extensions and it is super easy to work with. So does everybody have Node.js and VS Code in your system? Is there anybody who hasn't installed VS Code or Node.js in your system? Yes, VS Code. Any okay? How many fans of VS Code? Huge fan. Yes. I'm also in that camp. Any other Vim? Oh wow, we have a Vim. We have a Vim fan. That's nice. Used to be a fan of Atom. Yes. VS is yes. Okay. Nice. Cursor is. I've never used Cursor. Sublime text. Yes, that's good. But yeah, VS is better. I'm a fan of VS Code. So yeah. So anyway, so make sure that you have this, and at the end of this course, shifted from Sublime Text. Yes, everybody. I think for somebody who is starting out in Linux, you always start with Sublime Text and then move to VS Code. I don't know. Like a lot of my dev friends have done the same. I don't know why that crazy pattern is there, but it's there. But anyway, so you make sure that you have that, and at the end of this course, you will have this NFT. You'll get this NFT, and make sure that you just chill this NFT, tag the Meta School team, and just tell people that you are writing your first smart contract or building stuff, right? So be accountable. Like there is no point in keeping all the building stuff secret. Like tell the world that you're building, right? Show the world that you're a developer. Awesome. All right, and the greatest thing about the Meta School Oh, Manav, let's see, man, let's see. So the thing is, this whole course is open source, meaning you can it's there in GitHub. So if there is any mistakes or errors that you find in the course, feel free to update it, put a PR and everything, right? All right. So moving on. So the first step is we need to have the VS Code and Node.js, and the next thing is we need something called as MetaMask. What is MetaMask? What's the whole idea behind MetaMask? Wallet, crypto wallet, browser-based wallet. Yes. And why do we need MetaMask? Interact with blockchain. Yeah. Like, why do you need MetaMask? It's like asking why do you need an account to interact with the banking network, right? Sign applications and stuff. Like, like when you're yeah, to pay, to hold tokens, to interact with the blockchains. Yes, gateway to blockchain. Yeah, that's the thing. Like we established that these smart contracts are written on top of, or deployed on top of blockchains, right? So the thing is, it's just like a banking. Like you can compare this blockchain to a banking network. Like in order to do anything in a banking network, what is the first thing that you need? Like to take loans or to put some money or transfer some money. What is the first? Yeah, bank account, right? So just like that, in order to interact with the blockchain, the first thing that you need is an account, right? You need an account address or within that particular protocol, even if it is Bitcoin, Ethereum, or some or any given protocol. And this MetaMask is something that helps you manage that account. Okay, it's a wallet application that helps you manage that account. So first and foremost, what you need to do is you need to make sure that you have a MetaMask wallet installed and you have an account, right? So to do that, how many of you have MetaMask account? Just share your public address in the Discord chat. Sagar, can you also share the Discord link? Like if there is anybody who's yet to join our Discord, please do join.
Sure.
Right? So I'll show you. So for those who are new or trying to set up the MetaMask, like how many of you have the MetaMask account? I think that was your first task. Okay, just paste your public address there. Yeah. Yes. I see Ibrahim has done it. Awesome. Awesome. Himanshu is on his way. It's curious. Yes. Just paste your public addresses here. Yes. Nice. Nice. So for those of you who I'll just show you how this works. So it's basically an extension, meaning you just have to go to the MetaMask site. I already have multiple wallets. Dude, you're showing off, man. I mean, this is what other wallets? Now I'm curious. So go to the MetaMask website. You have, like, based on your browser, it will show you this download icon. Download it. Like add to Chrome, add the extension. Trust wallet. Oh, wow. Okay. We have some. And once it's downloaded, yeah, you can see that it is added to Chrome. Nice, nice. Okay, I see a lot of wallet addresses here. Nice. And you can just set up, like you can see, create new wallet. I agree. You just have to give a password. I understand. Create a wallet. Okay, now this is something. This is something like I saw somebody asking this question. Donate some, dude, Shantanu. I mean, that's the most straightforward word to ask for cryptos, I guess. I'll also put my address too. So yeah. Yes. Shantanu's game is strong. He's like donate some cryptos. Anyway, so yeah, you have this secret recovery phrase. So this is not required for the operations of your MetaMask wallet, but in case something happens, you need this in order to recover. Okay, I saw somebody asking that question today. So airdrop. I'm sorry. Suddenly, the screen is too blurry. I don't know anything about airdrops. What is airdrops? No, you don't show people your secret phrase. Don't worry, this is a new wallet. You can hack if you want to. This is something. this is a completely new wallet. So feel free to hack away. Yeah, then yeah. Just copy this. No issues. So what are the words? Since you know all this, but in all seriousness, you are not actually supposed to show your recovery phrase, because if somebody has this, then they can actually get a hold of your account. Okay, I'm just showing this because you guys are my friends, right? You won't hack, right? You won't hack right? Yeah, you guys are nice people, right? Yeah, and once you have that little puzzle done, you get your account. That's it. So this is how easy it is to actually get your, and you can choose different networks, right? You can choose MetaMask, like all these all these networks that you wish. What is this whole concept of a testnet? What is the whole idea behind a testnet? Like you have mainnet and you have testnets. What's the difference there? Deploying smart contracts, yes. So it's like, yeah, you don't have to use, yes, it is basically a test environment, right? Like when you're developing something, you can't just, yes, sort of like a sandbox. That's a good example. Like, sort of like a sandbox where you get to test out everything. Like before you just deploy your stuff onto the mainnet and crash a major dApp, you can actually test out the working of the dApp in a testnet, right? And you have different test nets. I think Sepolia is the one that you should be using. So yeah, this is general MetaMask, and you have all the details here. Like you can go to the account details page and get all the details of your account, right? So this is it. So yeah, so that's the first thing that we need, a wallet, and this just tells you what are the steps required. Now, after the wallet is, after you have your wallet, like I showed you, like if you click on this whole short testnet, okay, yeah, short testnet thing, it will show you all these networks. So you can change the network to Sepolia. Sepolia is a very popular, Ethereum testnet. So yeah, the rest of this chapter shows you how to add Sepolia network and everything. And so the thing is, in Ethereum, even if you are in a testnet or mainnet, you need to pay some money to interact with it. Why is that? You need some tokens to interact with it. Why is that? Any idea? To pay, okay. But why isn't it free? I mean, I would definitely develop more if the whole thing is free. Gas, yeah. Why do we need gas? Not to get spam. Yes, exactly. See, yes, attack the chain. That's the thing. See, the thing is, think of Ethereum as a world computer. Okay, it's everywhere. Like anybody can access it, right? Anybody can access it. It's a world computer, right? It's a huge network. So a network of servers that everybody is hosting around the world, and people can deploy apps and everything, right? So think of it like this: if you run such a platform, like a global network, a global computer, and it is absolutely free, right? Anybody can compute, or anybody can have access to it for absolutely free. What is the worst thing that can happen? Like, let me put it this way. Let's suppose it's your birthday, right? And you bring, suppose you are in college or your classroom or somewhere, and you bring this really wonderful cake to the class, and you just place it at the center of the class and say that everybody feel free to have the cake. Do you think everybody in that class will get an equal share of that cake? It's your birthday, you place a really nice cake in the middle of your classroom and say that go at it, have your way with the cake. Do you think everybody will have or will get the same amount of cake. Why? Like there will be chaos, right? Everybody, like maybe the strongest guy will come in and just take a huge chunk out of it, right? Maybe there might be some people who might not get even a small piece of that cake, right? So the same thing exists when you're actually thinking about Ethereum. Yes, unfair distribution, right? So you have a world computer, you have these resources that are limited because you can't run a huge program on top of Ethereum. So it's the same situation as the cake. Unless there is a controlling mechanism, what will happen is there will be attackers or there will be people who will run massive programs and burn out all the resources, and what will happen is other people won't be able to get enough resources to run their apps, right? So in order to control this, what they did is they introduced this concept of a gas. So for any kind of computation that you want to perform on top of Ethereum, you have to pay, right? This ensures that nobody is running any kind of an infinite loop, or nobody is running an uncontrolled program or anything on top of Ethereum, right? Every computation that they do on top of the network has to be accountable, meaning they have to pay for it. This sort of makes sure that everybody gets access to, like there is a fair distribution of resources. Do you guys understand? That's why there is token, or that's why you have to pay for transaction even in the testnet, so that everybody has a fair chance of getting access to these resources, the Ethereum network resources. Do you guys understand? So, any questions or doubts there? Like those who are starting out. It's like Nitin has pointed out. It's about getting that fair access to that resources. Otherwise, I can just go ahead and run an infinite loop and exhaust all the resources in the network, right? But I can't do that. Yeah, the gas fees ensures that there is no resource wastage in the network, because for every computation you have to pay. So you can't run something like an infinite loop in the network, right? Because you will run out of money. So this ensures that there is no spamming of the network. There is no unfair wastage of resources or anything, right? That's the core principle. Do you guys understand? It's just like the cake scenario, but we are just controlling the whole thing. Like if you want to run a program that involves a lot of computation, you have to pay gas. So the thing is, when you are writing smart contracts, one of the most to get to that top 1% of smart contract developers, what you have to learn is the art of creating optimal smart contracts. Yeah, Web2 is Web2 is not a globally distributed decentralized network. Like there are people making money off it. Like AWS is not free. Google Cloud is not free. Like Ethereum is like, it is not, they have their own mechanisms to make money. When you look at Ethereum versus a computational platform like AWS or Google Cloud or anything, the thing is Ethereum is actually run by volunteers, like people who basically volunteer their resources and stuff, right? It's a more decentralized platform. So there is in Web3, Web2, there are mechanisms to do that, right? In Web3, you need some mechanism to do that. So gas, it also incentivizes the people who run these resources for us. Plus, it also makes sure that nobody is spamming the network and stuff. So you have that two, advantages there, right? Just compare it with like how AWS works. You have to pay for it, right? So similar mechanism here, but the fees is very comparatively less. Yeah, the gas money, yeah, like I said, the gas money, it obviously at the end of the day, it goes to the people who are helping you run that network or helping to keep that network up. It acts as their incentive, but the whole purpose is like it regulates the overuse of resources and stuff. So yeah, that's another philosophy. Like that's another like core idea behind gas. Like it is to incentivize, but there is also this spam control or resource fair resource distribution thing that is going on with the gas, right? So yeah. Anyway, back to the topic. So the thing is, so what I'm saying is like whenever you are interacting with a testnet or a mainnet, you need some tokens. You need to pay for your computations. So for to get some mainnet tokens, you have to do what Shantanu does post your account address there and ask for cryptos. For testnets, you have something called as faucets, okay, where they will give you free testnet tokens, right? So you can just paste your sign into Alchemy, just paste your address here, and you will get those Sepolia tokens. So you can use that to test your applications. So is there anybody who doesn't have these tokens in their account? Is there anybody who doesn't have that faucet? Like if there are people who doesn't have testnet tokens, please do ask the community. We are happy to share some of our tokens, right? So yeah, make sure that you have the testnet tokens too, right? It's quite easy. Just go to this link, sign into Alchemy, paste your wallet address there, and do the verification and just click on send me, and they will give you free test tokens. They are not worth anything. Don't go to an exchange and try to exchange the test tokens. They are worth nothing, but they will help you run your applications in the testnet. Okay. All right. So Getson, you are rich. You are officially rich. You have 25 Sepolia test tokens. So if anybody has any issues or testnet, yeah. So if anybody wants, oh wow, I'm surrounded by rich people. I have like 2 or 3 or something. I don't know. Billionaires, yeah. Yeah, I have 3. So yeah. Anyway. So yeah, make sure you have that. Yes. So you need testnet tokens to deploy your contract onto the testnet network. Okay, make sure you have those tokens. And if you are finding it difficult to get the tokens from the faucets, do share your public key address, public wallet address to the chat, and we will share some tokens. We are nice people here, so we'll share. So anyway, moving on. So once you have all that set, we need to use something called as a hard hat. What is a hard hat? Like I'm sure you guys have seen that yellow hat that people in construction wear. But what does that have to do with Web3? What is hard hat? No idea? Development tool, framework, yes. Ethereum development environment, yes, that's the official term that they use. But it's essentially a framework. Okay, so this is a hard hat. Like when you look at a hard hat framework, what it is actually a collection of libraries and tools and everything that you need in order to develop a smart contract. Okay, it's a culmination. It's a one big repository of tools and libraries that will help you easily develop your smart contracts. Okay, you have like you can either use hard hat or there is a very famous online IDE that you can use. I'm sure you guys have used it, or at least yes, exactly. So Remix, you can also use this thing called Remix IDE for writing smart contracts. But in this course, what we are doing is we are trying to help set up a smart contract development environment in your local system. Okay, because as you start to develop your projects and stuff, you need all these environments in your system, right? You can use Remix for quickly writing smart contracts, but as you go, as your product or as your project gets bigger, Ganesh is also fine. Ganesh is not a entire tool set. Like there is the truffle suite. Okay, Ganache is actually like Ganache is just local network that you can run, but there is something called as troubleshoot. But sadly, like people are actually setting it down. Like troubleshoot is I think it's depreciated already, but I have to check. Old, yeah. Oh, wow. Yeah. So this is how many of you started with the troubleshoot? Yeah, you can see that it's very sad news. Like it's actually a lot of us started with the troubleshoot, right? Yes, but yes, that's the thing. So but sadly, it's like uh, they are sunsetting it. So yeah, but Ganesh, you can use it's sort of like a local network that you can set up in your like it's a network dummy network that you can set up in your local system. You can use that. But Hard Hat has all those functionalities, right? I think Ganesh has a nice UI and stuff. Like with Hard Hat, you have to tinker a bit. But yeah, it's fun. Yeah, Hard Hat and Foundry. Cool, cool. So yeah, so you have to set up a Hard Hat project. So it's pretty easy. You have all the commands here. You need a new folder. You need npm. What is npm? So let me just go to the folder. Yeah. Yeah. Dummy. Yeah, exactly. Node package manager. Yes. It helps you manage all the node libraries and stuff. So what you have to do is you just have to copy that command. Yeah. And yes. So mkdir Linux spans. Foundry actually it's written using Rust, but in Foundry you actually use Solidity itself. Like for scripts, you use yeah, it's Ubuntu. I'm a huge fan of Ubuntu actually. So yeah. So what I'm doing is I'm just with those commands, I'm creating a hello world folder. I just in the terminal, I just moved into that directory. I am initializing a node project, like npm init means I'm initializing a node project. And to that project, I'm installing Hard Hat. Right? So that's what I'm doing. Yes. No, no. So the thing is, Foundry is actually written like the language. They wrote the whole Foundry framework using Rust. But within Foundry, you actually use Solidity for writing tests and everything. I know it sounds confusing. Yeah, Foundry is written in Rust. Yes, exactly. But you use Solidity for it, for the scripts and for the test also you'll use Solidity. I know it's confusing. The thing is, it's like this. Like this IDE, right? This IDE is actually written using JS. Like there is a JS framework that they use for VS Code, but within it, we can use any language. So it's the same concept. The Foundry as a framework, it is the language that they use to create Foundry is Rust. But within Foundry, when you're actually using that framework, you need to write the whole script and deploy script and everything using Solidity. That's it. So yeah, so we have the node package and everything. So let me just open the terminal here. So once you have that, what you have to do is you have to set up the Hard Hat project. So use this command, npx hard hat. I'll just paste it. Yes, yes. So yeah, this is so yeah, the Hard Hat project. So I'm going to create a JavaScript project. This is the root directory. Since I'm not pushing it, yeah, let's just keep a git ignore in case I want to push this code to GitHub. Yes, and so this is asking for a couple of additional dependencies that will be automatically installed with the project. So just click on yes, and it's installing that dependency. Now, as you can see, when we are setting up the Hard Hat project, a lot of directories pop up. we have your attendance. Yeah, you have the dashboard, right? So all the call details and everything will be there in the dashboard. But yeah, don't worry, we have your attendance. So yeah, so as you can see, like when you're setting up the project, you have these different directories. Like you have the contract directories where you will store your smart parts. You have the scripts folder where you'll be writing things to deploy the script, and you have the test folder where you'll be writing the test, like all the testing things and stuff, right? To test the contract. Is testing really important? Like, do you think like you need to test? Don't worry, if you're in the call, so Ashish, if you're in the call, your attendance is marked. Yes, right. So, right. So I think that is actually one of the biggest USPs of hard hat. Like it is super easy to test with hard hat. Okay. So yeah, we have set up a hard hat project. So you can see that there are different folders with contracts and stuff. We'll go through them. But before that, we need some additional packages that we'll be installing. Like all the details of the packages are here. It's basically an ethers library and stuff like that. So let me just install that too. I have a question. And there is another. Okay, if you can share the error, we can help. Like when you are pushing it to GitHub, if there is any particular error that you're facing, just share it in the chat and we can help. Okay, so what I'm doing is, as the next step, so I'm just installing some additional libraries. Okay, and then you are done. So just remember the steps. Set up a wallet like MetaMask. Connect to the test network. Get some tokens to interact with the test network, like deploy your contract on the test network. Get the framework, like set up the hard hat framework project, and install all the additional packages that comes with it, like all the dependencies and everything that comes with it. Any questions? Any questions so far? So we created the project. We have the wallet. We have the address. We have the test tokens and everything, right? All right. And there is a really cool that this is why I love VS Code. Like if you go here and you search for a hard hat. Oh wait, no, no. Yeah. There is a really cool extension for hard hat. You can see the Solidity Nomic Foundation. These are the guys behind hard hat. Okay, so you can just install. I have already installed it, but you can just install this, extension. So a lot of things will come easy. So yes, so we finally have the project and everything ready. So at the end, you will have a small assignment. Just submit this and submit your wallet address, and we are good. Okay, so I'll give you a 2-minute break if you have any questions. So we are all ready to start our code. So we set up all the environments. We have the testnet set. We have the tokens. We have the wallet. So we'll just take a 2-minute break before we start writing the code. If you have any questions, queries, anything, you can ask. Anybody? Any questions? Is this clear? Like all these things clear? You can, yeah. So there is a, yeah. Yeah. So the thing is for, yeah, there is, I think there is another extension too. I'm just saying that if you're using hard hat, there is a specific extension for hard hat from the same team. There is also a Solidity extension too. You can use that. That's fine. I think there is a Solidity. This is the extension that you're talking about, right? Yes, yes. You can install, yeah. You can install both. This is from the hard hat team itself. So a lot of code completions and everything from hard hat can be handled using this. So that's why I said, like, you can install that too, no issues. Yeah, so maybe since we are using hard hat, maybe just stick with the hard hat extension. You know, yeah. So, the thing is, you need make sure that you have the testnet tokens, okay? Because whenever you are doing some computation, when you are running some applications in the testnet or deploying some contracts or something in the testnet, you need tokens, because there also you need to pay for the computation. Otherwise, the exact same situation will happen in the testnet too. But in it is quite easy to get testnet tokens. Like you have faucets or you have getset, right? You can choose any of them, and they'll give you the testnet tokens. So yeah. So any questions, doubts? Is this clear? Can we start the coding part? Yes, Getson is a testnet. Yes. Okay. Clear. Nice. Yeah. So this entire course, like it is there in Meta School. Okay. Okay, so in case like after this, like it is really nice if you are coding along, but if you are not able to do that, just go through this lesson. It's all there, like all the explanations. I'm just giving you a walkthrough and helping you understand the fundamentals of it. Okay. Okay, nice, nice. But if there is any errors at all, just let us know. Okay, everything is step by step. It is given in detail in this course. I'm giving you a overview or a walkthrough of it, right? So yeah, let's start with the code. Let's start with the Solidity. So you can see that you have the Solidity contract here. So what you have to do is you can just copy this. Yeah, and there is like when you set up the hard hat project, there is a default contract that hard hat provides. You can either delete this file, no issues. I'll just delete this and create a new file called hello world. So, and I'll just paste that contract there. Yeah. So the next session, like writing the actual code. Once you set up the environment, just go to the next, click on the next, and it will take you. You mean, okay, you mean the course? Okay, Sagar, can you please share that course link?
Yeah, sure. All right.
Yeah, so if you're looking for that course main section, just I think Sagar will just share the course link right now. Okay, so yeah, back to the code. So this is how you write. Yeah, there you go. So just a second, I think. Okay. So this is our basic smart contract. So you can use any versions like greater than. So we'll just break this down. But before that, when you're creating the hard hat, yeah, when you're creating the hard hat project, there is this little file called hardhat.config.js. Now this is your command center or your control center. Okay, this is your command or control center where everything about your hard hat project is configured here, like the Solidity version and everything. Okay, so this is like this is where, like, if you want to change anything regarding the project, the configurations of the project, this is the file. So never ever delete this file. Okay, this is like the most important file because it helps you with configuring everything about the project. So yeah, let's go. Yeah, you can change the version, no issues, like 0.8.9. That's fine. So yeah, So let us break down this contract. So what is this? I'm not. I saw that a lot of you guys have written. Also, the courses Road to Web3 is for that dashboard. Road to Web3, like courses / Road to Web3 is for the dashboard. Yeah. Like you can use that link to get to that dashboard. Okay. So yeah, what is this whole thing? Like SPDX license identifier? Do tell me, like I know that there are people who have written 20 plus smart contracts. So my job is cut short actually. Please do tell me what this is. Why do we need this identifier? Yes. See, most of this code will be transparent, like you are putting it onto a blockchain, right? So this means that people, like if they have the know-how, they can get to access to the code. No issues there. So you need some kind of a licensing. Like you can do unlicensed, or you can do MIT license, which gives people freedom to use the code and stuff like that. So it's for licensing, and then there is the Pragma Solidity version. So what is this? Yeah, exactly. Open sourcing, basically like that, a licensing for that, showing that there won't be any legal trouble if somebody uses this code or things like that. So yeah, the next one. All right, somebody is on my screen. Yes. So yeah, so the next line is Pragma Solidity, right? So, and what does this actually mean? Like Pragma Solidity, it is for the versions, and what does this actually mean? What does that line say about my contract? Yes, it is the Solidity version, but what does that line actually say about the contract? Yes, that means this contract is compatible with any version that is equal to or greater than 0.8.9, right? If I given this, it will be like just 0.8.9, but if this means that any version, yes, that's exactly it, right? And then we have the keyword like this, just like how many of you know C, C++? Like how many started with C, C++ in their school or in college while learning programming? Yeah, there we had this concept called class, right? Like where we define classes and everything. So just like that, we have a keyword called contract, and this is the name of my contract, right? So this is my contract is called Hello World. So within my contract, I have something called as an event. Any idea on what this is? What is the whole concept of an event? Async function? No. Yes. See, event is sort of like your notification mechanism. Gives notification. Yeah, exactly. Yes. See, you know, like how you whenever you have Instagram or Facebook installed on your mobile, whenever something is happening within that social media, maybe somebody is tagging you or somebody is posting something about you, you get a notification in your phone, right? It tells you that something is happening there, and through that notification, you get awareness about it. Yeah, I haven't run the code actually. I'm just explaining it. I'll show you how to run the code. So this is sort of like the same thing. This basically helps you, this event mechanism, it actually helps you share information that is happening within the contract to the outside entities, whoever it is. It can be a front-end application or whatever. Okay, so this event helps you actually, just like your notification mechanism, it actually helps you share the data or share the changes within the contract. Okay, so that you can keep track of it or use it for something else, whatever may be the reason. It helps you, share data from within the contract to any other outside entities. Okay, so yeah, so the whole contract, what it does is it takes in a message And this contract has a function to update that message. That's it. It's a very simple contract. And this is, what is this? Any idea on this? What this is? The 11th line. See, this is essentially a variable in the contract. Okay. There are different kinds of variables, but this is basically a string variable in Solidity. You can have other variables like uint, a bool, or whatever. Yeah. So public means so the idea is this public. There are other keywords too, but what it does is it manages the visibility of that variable. Okay, meaning if I say that this variable is a public, it means that anybody can access the data in that variable. Okay, yes. Visibility specifier. Yes. What it says is that anybody, so in this program, when somebody is interacting with the contract, anybody can access the data in this variable. Okay, there are other visibility specifiers like private. Any idea on what this does? So public means anybody can access it. Okay, public variable means anybody can access the data, or anybody, this variable will be visible to everybody. So what is the whole idea of, yes, private means, like if I say this is a private variable, it means that only this, only the functions or functions within this contract, so only the entities within this contract gets to access this variable, or this variable will only be visible to the entities within the contract. Then there is something called internal. Any idea on what that is? So internal means that this variable will be visible to this contract and any other contract that is inherited from this contract. Do you guys know the concept of inheritance? Right? You have a contract and you are creating another contract out of the first one. That is inheritance. So if you give the contract visibility, the variable visibility as internal, it will be visible to this contract and any contract that it inherits from, or that is inherited from this one. Okay, so these are the three main, like private, public, and internal. Yes. So for variables, you have these three visibility specifiers. Now, coming to functions. So this is how you write a variable in Solidity. You provide the data, the data type of the variable. You specify whether it is the visibility specifier like public, internal, like private, or whatever. So here it's public. Do you know what is the default visibility specifier? Like default visibility of the variable in Solidity? No, it's actually internal. Yes, for variables, it's internal. Okay, so you have the same mechanisms for functions. Like you can specify the visibility of functions too. We'll get to that. Okay, let's just stick with variables for now. So for variables, this is how you do it. You provide the data type, the visibility, and the name of the variable. Right? That's how you, and the data type can be anything, string, number, string, uint, bool, whatever. And so the next is something called as constructor. What exactly is that? So external is not for, that's what I'm telling. External is not for the variables. It's for functions. We'll get to that. We'll get to that. Okay, so what is this whole thing of constructor? Or how can we access a constructor? What is, yes, a function that is executed once. Okay. Any other definitions? Yes. So this is actually a very special kind of a function. Okay, this is constructor is a function, but it's a very special kind of a function. So this function is automatically called when we deploy the function. Deploy the contract. Yes. And the purpose of this constructor is it helps you set the initial values for the default states or data for your variables and stuff. Okay. It's like when you start a game, you have a default setting that is already there, right? So a constructor helps you set that default settings for your contract when you deploy it. Okay, you don't have to call that constructor, it is automatically executed. And just like how you have those default settings in the game when you start it, whenever you deploy the contract, it will execute the constructor and it will manage all the default values and everything. Okay, any questions? Any questions here regarding constructor? So this is the first function. Yeah, okay. So constructor is a very it's a function, and the purpose of this function is to set the default values required for your for your contract. Okay, like you need, maybe if you're let's say you are uh, creating a contract for a voting contract or something like that. Okay, and you need, whenever you start the contract, you need to make sure that the names of the candidates are already there. When you start the contract, you need the names of the candidates there, right? So for that, what you will do is you will put all those names, or those you assign all those names in the constructor. So what this constructor does is, when you deploy that contract, or when that instance of that contract is deployed onto the blockchain, this constructor function will be automatically executed. Okay, and based on, and that after execution, the data that is provided within all these default settings will be automatically set. So when you start your contract, you will have all the default values that you need. Okay, so this is mainly used to set the initial or default values that are required in your contract. Okay, you have other functions too where you can update or modify these things. But for the initial values, in order to set the initial values, you use the constructor, which is all automatically executed when you deploy the contract, right? And then you have the function. So function, as you know, like this is where you give all the logic for handling your data and everything, right? So this is how you give your function. You have the function name, you have the function keyword, the name, you have the list of parameters or the data that goes into the function, and you have the visibility specifier here. Okay, in function, just like the variables, you can specify the visibility. But the thing is, here you have an additional visibility called external. Okay, for functions, you have an additional visibility called external, right? So any guesses on what external is? You have private, meaning only the entities in the contract can access it. Public, meaning everybody can access it. Internal, meaning only that contract and the inherited contracts can access it. What is external? Yes, meaning only external entities can call that function, right? Yes, like entities outside the contract can call that function. So this is how you give the function, or this is how you define the function. Function keyword, name, parameters, and the visibility specifier. And if the function is returning something, meaning if there is any data that is coming out of the function, you have to specify that too using the returns keyword. Okay, here, since we are not returning anything, we can just say this. So let me ask you this. So what do you call this property where in Solidity you see that every data, like you have to specify the data of a variable, or you have to specify a lot of things about this function? What is that property called? Like when you look at a language like JavaScript, you don't need to do all this. Yes, strict type, exactly. Right, statically type or strict type language, where you have to specify the kind of data that you are using. Static type, yes, statically typed languages. Like Solidity is actually a statically typed language, meaning you have to specify everything beforehand. Okay, unlike Python or JavaScript or those kind of languages, here you have to specify the data that goes in, or the kind of data that you will be using or returning, or all these things. Okay. So here, so in the constructor, what we are doing is, you can see that we have the message variable here, right? And in the constructor, we are giving the initial value to the message variable. This memory keyword, this is a keyword that specifies where we'll be storing. We'll get to that as we move along. But the idea is that This basically tells that the value that comes in as the parameter should be stored temporarily. Okay, not permanently, but temporarily in the memory. That's it. Once this execution is done, the value it will be removed from memory and it will be stored to a variable, as in this case. Okay, so this memory keyword basically tells that this value should be stored only temporarily, and we will just pass on this value to a variable which will be stored onto the state. Okay, so with the constructor, what we are doing is setting the init value for the message variable. Okay, so that is what the constructor does. And in this function, what we are doing is replacing the value in the message. New one. So in the function, we are taking in a new message and we will replace the old message of that is in the message variable with the new one. And we will emit saying that, okay, this old message has been replaced, or this emit keyword is used to call this event, or it is used to notify that something happened in the contract. And here what is happening is we are changing the old message to the new one. So we are passing the data. This is the old message and this is the new message. Okay, so this is a very basic contract where we have a variable called message. We use the constructor to set the initial value of that message variable. Then we have a function to update that value of that message variable. Okay, this is the basic contract that we are going to write. Any questions here? Any doubts or questions? It's pretty clear. It's pretty simple, right? Like if you have any questions, like just go through this course. Okay. It explains everything. States, everything is explained here. I'm just giving you a walkthrough of it. So just go through it and you will understand what is happening. So the next step is to, in order to see if there is any error with the contract, what you have to do is you have to compile this contract. What do you mean by compilation? Yeah, so okay, so initially we will set a default. So for those who are if this is not clear, what is happening is initially we are setting the default value of the message, then using the function we are updating it. Okay, we set an initial value with the constructor, then using the update keyword we are updating it. That's it. All right, so yeah, what does compilation mean? Running the code line by line. Okay, any other examples? What is the whole? Yes. See, what you have to understand is Ethereum doesn't understand Solidity. Okay, Ethereum network doesn't understand Solidity. In order for it to understand this whole logic of your rules or code or anything, you need to convert the code into something. You need to convert the code into something that is that can be understood by the machine itself, right? That's where compilation comes. So if there is any error with the code or anything that this compiler cannot translate, it will throw an error. Okay, so in order to quickly check if there is any issue with the contract, what you have to do is you just have to compile it. And in order to compile the contract, you use the npx hard compile keyword, right? Yes, it's sort of like it's translating language from this high level code to machine understandable format. So let's see if there is any error. Npx hard compile. Yes, you can see that compiled one Solidity file successfully. And once this is compiled, you can see a new folder popped up called artifacts. So within the artifacts, you have this contracts hello world, which is the files related to the contract. And within this, we have something called hello world.json, right? So within this file, you can see all the compilation detail. Like these are like you have something called the ABI, and you have the bytecode, or this is the translated version of the code. Okay, this is the way that this is not actually exactly the way, but this is how the machine will be, or this is how the code will be stored in the blockchain. Okay, it is compiled into something that the machine can understand. And then there is something called as the ABI. Okay, now this is sort of like a map to your entire contract. You need this, like I'll show you where this is required, but this ABI, think of it like a map. What it does is it will tell you everything about everything that is there in the contract, like all the functions and all the inputs required by the functions and everything. It is like this ABI is sort of like a map that tells you all the details about the contract functions and how to interact with it. Like what are the inputs, what are the outputs, everything will be there within the ABI. Okay, so this file is created, or this artifacts folder is created when you compile the contract. It's exactly like the blueprint. Yes, the blueprint or the map. You can use any given ways to describe it. But the idea is that ABI gives you the complete understanding of the contract. So when you are interacting with the contract, you need to use the ABI, because that tells you what is there and what is not there in the contract. Okay, so yeah, we'll use it now. So we have a contract ready, and now let's deploy the contract. So any questions here? Any questions? So we are going to, we completed our first contract. We compiled it. Everything is good so far. Now let's deploy it onto a test network. Any questions so far? Any questions or doubts? It's pretty clear, right? Awesome. So yes, exactly. ABI is an object that has all the information required to interact with the contract. Okay, so in order to deploy the contract, one of the first things that you need is something called as the MetaMask private key. See, the thing is, when you are actually deploying the contract, what you are doing is you are sending a transaction to the Ethereum network saying that you need to deploy this contract, or you need to put this contract onto the network. Okay, and in Ethereum, you need to specify the account from which you are doing this, right? Just like your bank, like just like how you're doing with bank. Like when you go to the ATM, it's not like you just wave your card and say that I need money, right? You go to your ATM, you put the card, you put a PIN to identify yourself, and then you extract the money, right? So just like that, in the case of Ethereum, in order to deploy or in order to conduct the transaction, you need the private key. The private key of your account is exactly like your PIN code, your ATM PIN code, right? It verifies your identity to the network. I put a private key on a repo for dude. Yeah, this is why you should never share. I think Jimmy just gave the most amazing example of why you should never share your private key. Okay, so it's just like I said, it's just like your PIN code. What happens if somebody gets hold of your PIN code, like your credit card or debit card PIN code, security code? You know, they can just wipe out the account clean, right? So this is exactly the same thing. So the thing is, when in order to deploy the contract, but you need to access the private key. But it is never a good practice to share or put the private key directly in the code. For that, what we do is we use something called as environment variables. Okay, meaning your private key, yes. What happens is your private key won't be shared with the code when you're using environment variables. Okay, it will be stored within the system, and your code will pick up the private key from the system itself. Okay, so don't directly give your private keys with the code. Always use environment variables. Okay, and you have this nice little package in Node.js that actually helps you handle environment variables. So first install the package, and in the project root structure, give create a new file called .env. Okay, within this file, you can share, you can store your private key, which will be picked up by the code. Okay, so you are not directly exposing the private key, right? So remember that your private key is just like your ATM pin code. Never share it with anybody. Okay, and in order to access your private key, what you have to do is, don't worry, I will not be showing the private key. I will just show you how to get it, because I don't want my 3 Sepolias hacked. So yeah. So yeah, so go to this account details, show private key. It will ask you for the password. And once you have that, just click on this and it will give you. Okay, you have to be quick with that. And it will show you the private key. Just copy paste it. Okay. Let me get my private key. So any questions or doubts so far? Any? Yeah, don't be lazy. Use environment variables. Exactly. Any questions or doubts so far regarding any of these processes? It's all there in the lesson. So yeah, create a .env file, copy this. In the .env file, just copy this here. And here, instead of this, just paste your private from MetaMask. Let me just do that in absolute secrecy. Yeah. All right. Okay. So I have my private key in the .env file. Let me just close that. All right. So yeah, any questions or doubts so far? It's not that I don't trust you guys. I'm just showing you some best practices. Okay. All right. So yeah. And once you have that, you need access to a node. Okay. So why is that? Why is that? Any idea? See, think of it like this. Okay, I'll give you to understand why you need this node, and I go to Alchemy and set up a project and everything. See, whenever you're conducting some transactions with the bank, right? You need some kind of a touch point in order to interact with the banking network, right? You either need a banking app, you either need access to an ATM, or you have to go to that branch, like a particular branch or something, right? You need some kind of a touch point to interact with the banking network, right? So just like that, in order to interact with the blockchain network, you need a node. Okay, you need access to a node. Yes, yes, exactly. It bridges you, yes. But the thing is, and the reason why you use these platforms like Alchemy is because it is super hard. You can run a node on your own, right? You can use the system to run a blockchain Ethereum node on your own, but it is super difficult. And it takes a lot of these resources. Like it takes a lot of computation energy and power to run a node. So these platforms like Alchemy, ChainStack, Infura, what they do is they help you set up the whole thing. Like they will take care of all the overheads that is required to run a node, and they will just give you access to it. Okay, so just go to this platform, create a new dApp, just fill in like we are not using mainnet, we are using Sepolia. Give a name, any name is fine. And okay. And some description and create app. I have already created an app for this. So it will have something, and you when you create an app, you will have a nice little dashboard of your node, and just click on this API key, copy this HTTPS one. Okay, for that. So so with the Alchemy platform, what you're doing is you are accessing a node, and in order to interact with a blockchain, you need that access. It's just like a banking network. You need the banking app, or you need access to an ATM or the branch of that bank in order to access that network, right? So similarly with blockchains, you need access to a node. Okay, so you get that HTTPS link, and you need to paste it in the hard hat config.js. Before that, we just have to make a few modifications here. Okay, so you can see that here we have stored our private key, which we get like using the .env package. We are calling that variable from the .env file. Okay, the private key variable. Make sure that the variable is like this is the exact same words that you use. Make sure that there is no typo or anything. And you're giving the network details and everything. So here you have to paste that HTTP link. So go to the dashboard. Copy this. Paste it here. All right. So as you can see, we are giving the details of our network. Like so for Sepolia, we will use this link to connect to the node, and we'll be using this account to do our transactions. Right? Any questions here? Any questions or doubts here? This is how you modify. You can see that this tells you all the packages that we need for the project. All the setup, like the configuration, the default network that we'll be using, the details of that network and everything, right? So we have everything set for our hard hat project. Now all we need to do is write some code to deploy the script, deploy the contract, right? So any questions, doubts, anything? Anybody have any questions or doubts? We wrote our smart contract, we compiled it. Now we are on our way to deploy it. And in order to deploy or interact with the network, we need access to a node. And we do that via the Alchemy platform. Okay. Any doubts so far? You don't have to. Like for this, you don't have to use the API key separately. You just need just copy the whole link as it is. This API key is already there. You can see this. It is already attached with the link. So just copy this. Okay. All right. And yeah, ask a query. Like if you have any questions, this is the little assignment that you need. Okay. So once you have all that set, we need to write our deployment script. So I'll just copy this and I'll show you what is happening. So here there is the scripts folder. Within this, there is deploy.js. Click on this. Just remove this and paste this. So this is basically a JavaScript file. Okay. You have an asynchronous function. What is asynchronous function? I see that a lot of you guys understand what JavaScript is and know what Node.js is. So what is asynchronous function? No idea. See, any idea? Yes, sure. You can use this Alchemy same address for a lot of apps. Like so, the thing is, you have to keep in mind the network. Like this is set up for Sepolia. Okay, if you are using Polygon, you have to create another app for Polygon. Okay, you have to set up another app for Polygon. Let's say if you want Polygon network, you have to click on that and create the app. This is just for Sepolia. Yes, running without blocking, exactly. See, this what it does is like when you are when it is synchronous code or normal code, what happens is if there is any functions or anything that takes a time, what happens is like you have to go step by step. Like step one, this will be executed first. Then it will once this line is executed, then it will go to the other one. Even if it takes a longer time, every step will go one after the other. No. Oh, yeah, I'm just explaining the deploy.js file, right? So that is the whole synchronous method, or meaning the normal method of function execution. What asynchronous function does is like you can run things in parallel. Think of it like you're cooking up a meal, right? Is it like you just put the gas there, you switch on you just put the pan in the gas, you switch it on, you wait until it heats, then go cook the vegetables. Is that how it works? When you're cooking, what are you doing? You just put the pan and you just switch on the flame, then go cut the vegetables. You will be doing a lot of stuff in parallel, right? You'll be doing a lot of stuff in parallel when you're cooking. It's not like you will wait for the water to boil and then go for cutting the vegetables and stuff like that. You'll just switch on the fire and then go cut the vegetables, take all the spices or whatever. All these things happen in parallel, right? So this is basically the same thing. So in asynchronous code, it won't wait for the execution of a particular line to complete. Multiple lines will run in parallel, so that, and once they are executed, like the whole thing comes into place. Yes, exactly. While other things are running, just think of it like you're cooking up, like your typical cooking exercise, right? It's not like you wait for one thing to end and then go for the next, right? You'll be doing multiple things in parallel while you're cooking, right? Exactly the same thing. That's basically asynchronous programming. We'll be using more functions as we start developing more apps. I'll explain it further then. Okay, for now, just know that all these lines can run in parallel without waiting for each other to actually complete. But there are some mechanisms that will synchronize everything, but we'll talk about that in the future. But now know that all these things will run in parallel. So what happens is, so within this function here, what is happening is you have this get contract factory command, right? So this will fetch all these details. Okay, all the details that were produced out of the compilation, right? So this get contract factory, it will fetch, it will basically target this file, hello world.json file. So get contract factory, when you run that function, what it will do is it automatically goes to this folder and get the details from this JSON file. Okay, so it will get that details, and using this deploy function, and we are attaching those details to this variable, and with this variable we use the deploy function. Yeah, so it runs in parallel. Like there are exceptions to it, but essentially when you're using an async function, it won't wait for one line of code to end. Or suppose like when you're writing the code in asynchronous, you have to fetch some data from the internet or some server, which can take time, right? You have a line of code that fetches some data from the internet, which can take time. So in asynchronous programming, other lines of code won't wait for this code to end. It will run in parallel. Okay, so yeah, here what we are doing is we are getting the details of this contract called the hello world. So it will just go and fetch the details from this hello world.json file. We are attaching to this variable, and we are using the deploy keyword to deploy the contract. Right? We have the information that we need, like the bytecode and everything is ready to be deployed. So using the deploy keyword, we are deploying that contract onto the network. Any idea? Can anybody tell me what this is? Why are we giving hello world bingo here? Or where does this data go? Anybody? Exactly. See, this is the data that we initially pass to the constructor. Yes, this is the initial value. Okay, when we deploy, within the deploy, this value goes to the constructor. Right? And so, yeah, so we are deploying it and we are waiting for the transaction to complete, getting the hash and waiting for the transaction to complete. And once the transaction is completed, we will get the contract address. It's simple line of code. And in order to run this, yeah, we have done all this. The compilation, we can do this now. Or the thing is, when we are running this file, the compilation is automatically done. I'll show you. I'll just delete this folder. Okay. So this is the script. This is the code to run the script. Okay. And when the script is running, it will automatically do a compilation. Like this script will automatically do that compilation. You can see that artifacts is done because it needs this data to deploy the contract. And you can see that the contract is being deployed, right? And we within the compilation, like the deployment command, we are giving the network and everything. Since we have already set it here as the default network, we don't need to give this flag. Okay, this is just to explain the network. We don't need to give this flag because we have already set this as our default network. Meaning every script that we run will be automatically directed to this Sepolia network using this link. Okay, and now you can see that the contract address is deployed. Meaning our contract is deployed onto the Sepolia network. Now, how can I search for this? What is that tool that I can use or that platform that I can use to search for my contract to see if it is there? Yes, there is this infamous Etherscan. Yeah, so Etherscan is what you call a block explorer. Okay, it gives you a nice UI or nice insight into what is happening into in the network. So Etherscan helps you scan the Ethereum network. So here you can just change the network to Sepolia. So here I can see all the new transactions, blocks, everything that is happening in the Sepolia network. Yes, and just paste my contract. Like I have the contract address here, right? What I have to do is I just have to copy this. Okay. Copy this, paste it here, and just click on this. And you can see, there you go. This contract 1 minute ago it was created. Right? So your contract is ready. So yeah, when you use the Etherscan, make sure that you change the network. Okay. We are using Sepolia. So make sure that you change that. All right. So once you have that, you need the contract address, right? You need to store the contract address in your ENV. So just give me a second. All right. I have again successfully hidden my private key. This is like I said. Oh, wow. Okay, this is the contract address. So what you have to do is just copy this. And here just paste your contract address. Again, it's not that I don't trust you, but that is actually the a best practice. And I don't want my Sepolia stored. So yeah. Anyway, so just store it in the .env file along with your private key, and because we'll be using it. So contract address, the thing is, you can use it in the code directly, no issues there. Okay, but it is a good practice to actually use or store every variable or every such content in the .env file, because it is easy for you to access. Like if you want to change any of these variables, you just have to go to the .env file. You can use the contract address directly in the code, but a best practice would be to store it in .env. Okay. I can see the chat. So yeah, any questions? Anything? Yeah, you can. You can. Even the Alchemy URL can be stored in the .env file. That's also a best practice. All right, so we have deployed the contract, we have stored the contract address in the .env file. Now what we have to do is we explored it in this can. Now let's interact with it. Now let's see the code on how to call the functions in that contract. So for this, we'll be having a new, we have to create a new file called interact.js. So just go here. Yes. So yeah, and just paste the code. I'll explain the code in a second. Yeah. Again, a small code. Yeah, you can see that I'm getting the contract address, right, from the .env file. So this again, it is essentially doing the same step as last time. we are getting the hello world contract details. So this time what we need, I told you that in order to interact with the contract, we need the ABI and everything, right? So that is what we are looking for in this interact.js. Okay, when we are attaching, so I'll tell you. So you need two things. See, whenever you want to interact with a contract, you need two things, right? The first thing is the contract address, okay, which we have stored in the .env file. And the next is the ABI or the blueprint of the contract, which we get from this get contract factory, which is there in the variable. Okay, so whenever we are exactly like whenever we are trying to interact with the contract, we need the contract address and the ABI. Okay, yeah, we'll share the recording. Yeah, so this ABI, so it's like this: you're going to your friend's address, so let's say your friend lives in an unknown city. So what are the two things that you need to get to your friend's address? Sorry, your friend's home. You need the address and you need the map of the city, right? So just like that, your contract is somewhere there in the Ethereum network. Okay, so you need the address of the contract and the blueprint of it in order to interact with it, right? So that is what is happening here. Okay, then we are calling the functions. So here the thing is, you can see that there is a public variable called message, right? So this means that we can directly, and I told you, since it's a public, we can directly access that details of this variable, right? So that is what we are doing here. We are checking what is the initial value of this variable. Okay, the message, and then what we are doing is we are calling the update function with this statement, meaning we are changing the value of this message variable. And then again, we are calling the message variable to see if the value is updated. Now, let me ask you a question. Which of these things will cost me gas? So I read the message value, I update the message value, and then I read it again. Which operation costs gas? Exactly. Exactly. The update function. See, remember that I told you gas is for like gas is something that you pay for computation. Okay, or in Ethereum, computation means you are changing or updating or deleting something. Okay, when you are reading it, you are not making any kind of a change to the data, meaning reading data from a blockchain is free. You just need to pay for stuff that requires change in data. In this case, it will be the update function. Do you guys understand? So that is what we are doing here. We are getting the ABI and all the contract details. We are attaching it to the address so that we can easily interact with the contract. Then we are calling the functions of that contract. Right? Message, since it's a public variable, we will get that the message, the value of that message. Then we are calling the update function with the new statement that we want to put in that message variable, and then we are just calling that message variable again just to see if it is updated. All right. Any questions here? It's a pretty straightforward, right? Yeah, I mean, this entire thing is explained in detail in this function. You can see there is a line by line breakdown. I just gave the overview. Just go through it and you will understand. And we'll be also sharing the recording of this. So at the end, what you have to do is just copy this command. Any doubts with the script, with what we are doing? We are getting all the details of this contract from this JSON. It can, yes. Storage is also like you need to pay for storage. Bigger the string, bigger the pay. That's why you can't store a large file in Ethereum. That's why you can't actually store large files or stuff in Ethereum, because it costs a lot. Okay. So anyway, any questions with the logic or the how this contract, like how this script works? You are interacting. This script is for the interacting with the contract. We already deployed it with deploy.js. Now we are interacting with it. Any doubts there? Any questions or doubts? Awesome. Awesome. So yeah, let's just try and run this. So this will take time because it is interacting directly with the testnet. You can see that it gets the first message, which is hello world bingo. Then it is trying to update this. Okay, update this with the new message. And once it's updated, it will call this function to see the new message. Let's see if it works. It is taking time. Yes, yes, exactly. As Jimmy said, like there is a state to the contract. You can read the state, but to change or make changes to the state, you need to pay gas. So the account, so whichever account's private key that you give here, that will be the account where the gas is deducted from. Okay. The private key, like I said, the private key is like your control to the account. So all the gas will be deducted from the account that, of this private key, to which this private key belongs to. In my case, it will be my this account. You can see, I think you can see this here. Like usually when you look at this, you will see all the. But yeah, you can see that the message is updated, meaning our script is working. Okay, so we have successfully written our first contract. Why is it's not showing my activities? That's strange. Anyway, I'll figure that out. But usually it shows all the transactions and stuff. I don't know what's happening. Yeah, so we have successfully read the data from the contract and changed it to the new statement that we have given. Okay, so yeah, any doubts so far? So we wrote our first contract. We using the hard hat framework, we deployed it to the Sepolia testnet, and we interacted with it. And we did like any questions at any stage of this. Oh, okay. Yeah. Now, if you go to the Explorer, if you go to the contract address, you can see all the transactions. Like there you go, like the update transaction and everything. Okay. Oh yeah. All the action here. Yes. But yeah, any doubts regarding this whole thing? Any questions or doubts? You can, if you paste this, you can see all the activities that happened. Like 2 minutes ago, I updated it, all these things. Yeah, so if you have any doubts, Hamza, just post a query on Discord. Okay, it might be due to some kind of errors with the balance or something. Just post it on Discord. All right. So yeah, now the NFT one. So the thing is, we send our NFTs via Polygon network. So after the course is done, you will get your NFTs. Like this message is already there, and once you complete it, you will get your NFTs. To see this NFT, just go to Polygon NFT Explorer. There is the Polygon NFT Explorer. Just go there, paste your address, because we send it via Polygon. Okay. I don't know why it's taking some time. Yeah, okay. Go to the Polygon Explorer and just paste your address there. Not the testnet, Mumbai testnet, the main, like, we play classy. We send it via the real Polygon network. and just paste your address here, and you can actually see the Meta School NFTs and everything. I don't know why my internet is stuck. And you can import it if you want. Okay, but yeah, there you go. Okay. Just not. Yes, you can see all the Meta School NFTs and stuff. Okay, and you can import it. Also, this is how you can view the NFTs that comes to your account. All right. So, any questions? I think we are 3 minutes past our timeline. So, any questions, doubts, anything? Okay. So, like I said, every oh, thank you for that. So every detail is right here. Okay, I just gave you a logical overview of all this. Just go through the course, complete the course. Sethu for president. All right, why not? Anyway, so there will be a detailed breakdown in the course. Do go through the course. If you have any questions, post it in Discord. We'll be sharing the recording. Go through it, and if you have any doubts, ask our Discord community. And always make sure to share your learnings and buildings and everything on Twitter or LinkedIn, right? And tag us too, right? So, like I said, let the world know that you guys are building, right? All right, thank you guys. I think that's it. It was great. Like I love conducting these sessions, especially with such an active crowd. So it's really great. We'll see you. Like this is just the beginning. Like this is the learning part. In the coming weeks, we will also start the building part where you get to build teams and build applications and everything. So yeah, this was awesome. I think we have another call on Wednesday. We'll be discussing some cool ideas and stuff. So yeah, thank you guys. Have a great night. Yeah, like have a great day, I guess. Yeah, goodbye guys. All right,
Thank you so much, guys. Bye bye. Take care.
bye.